everyone. My name is Lee from the University of South Carolina. Today I'm going to be talking about the child identification of smartphones automatic and user-friendly. It is not surprising that kids in their early age start to use smartphones to take photos, watch videos, and play games. In the meantime, kids may face dangers on smart devices if not guided properly. For example, children can potentially access violent and adult-only content on the internet. That may lead to mental illness. And in addition, since parents and the children often share the same smartphones at home, and children may be able to leave private photos or account information unintentionally, that may cause, privacy damages to their parents. Third, kids may accidentally purchase goods on the internet without parents' consent and cause monetary damages to their parents. So it is critical to identify child users on smartphones and protect both children and their parents when they share the same mobile devices. Traditionally, parents take the responsibility for monitoring and guiding their children to use smartphones. However, it is time and energy consuming. Alternatively, parental control apps installed on smartphones can help parents to monitor their children's smartphone use. But these apps require parents to activate them before giving the phones to their kids. As human beings, we cannot ensure that it will never be forgotten. There also exist some approaches to collecting sensitive data to identify child users, such as face images or audio clips. But this data may not be always available for continuous identification. In this paper, we use touch patterns on smartphones to detect child users. We choose touch behaviors due to the following advantages. First, touch behaviors work well for automatic and continuous monitoring, since touch operations are necessary inputs as long as we use smartphones. Second, the monitoring can be implicit because the inference of touch behaviors is based on normal operations on smartphones without users' special attention. Thirdly, touch data is relatively insensitive and is privacy friendly. Previous studies have demonstrated that people have individually unique touch patterns on smart devices. Based on this finding, we first assume that the touch patterns are also age-related. We made such an assumption because of two observations. First, we observe that children normally have smaller hands and shorter fingertips. Their hand strength is also weaker. In short, the hand geometry is different between adults and children. Second, considering that children's bodies and fingers have yet to be fully developed, their finger dexterity is relatively poor compared to adults. These two observations make us believe that touch patterns may be age-related and can be used for identifying child users on smartphones. Here is the illustration of our touch-based approach. We name it as iCare. We envision that iCare can work as follows. Once a smartphone is unlocked, the iCare starts to collect touch data in the background and then detect the age group of the user. If the user is a child, it will automatically enter the child mode and block the user from inappropriate content. And every time the phone is unlocked, will trigger our system iCare, and it will enter the corresponding mode automatically. Note that we can easily adapt our approach to continuous monitoring as needed. In this paper, we mainly focused on child identification based on touches on smartphones. We extracted the features in terms of hand geometry and finger dexterity from the touch data. Then we train models for classification. We collected two types of touch gestures using two scenarios. In the first scenario, we collect taps by asking users to unlock the phones. In the second scenario, we ask users to play a puzzle game to collect swipes. Users need to swipe horizontally and vertically to finish the task. We have two groups of participants. The child group consists of 17 users aged from 3 to 11 years old, and the adult group contains 14 participants aged from 20 to 60 years old. In total, we collected about 3,400 swipes from children and about 3,600 swipes from adults. We also collected about 1,300 taps from children and about 700 taps from adults. Next, we extract the features of hand geometry and finger dexterity from the touch data. We got 35 sub-features from swipes and 8 sub-features from taps. Regarding the hand geometry, we mainly consider the touch size, the touch pressure, and the touch range. Regarding the feature of finger dexterity, we may explore the velocity, acceleration, stroke duration, and so on. We studied the 3 machine learning algorithms for classification, namely SVM, random forest, and k-nearest neighbors. The classifiers make a binary decision. Is a child or an adult. Our experiments want to answer 3 questions. First, we want to figure out which gesture and the classifier work better in the classification. Second, we want to see how the children in different age groups affect the classification. Thirdly, we will check the performance changes with an increasing number of touch strokes. We use 2 evaluation metrics in this paper, equal error rate and the area under the ROC curve. A lower EER indicates a better classifier, while a higher AUC indicates a better classifier. To answer the first question, we tested the 3 classifiers on the swipe and the tap dataset separately. We found all the classifiers achieve better performance on the swipe dataset than that on the tap dataset. And The left value of the legend indicates the EER, and the right value indicates the AUC. We also find that SVM and the random forest surpass K nearest neighbors on both datasets. Both RF and random forest can reach roughly 16% EER and about 90% AUC on swipe dataset. To understand the influence of children from different age groups on the classification, we divided the children into two groups and tested the classifiers. The group of GY children consists of younger children aged from 3 to 5 years old, and the group of GO children contains the older children aged from 6 to 11 years old. For this task, we only test the random forest classifier. We tested it on both swipe and tap dataset. For both datasets, we achieve a much better performance in identifying the younger children. The finding is reasonable because younger children tend to be more different with adults in terms of hand geometry and finger dexterity. We further explore the impact of combining different number of touch strokes for classification. We tested the classifier of random forest only on the swipe dataset, that is relatively larger than the tap dataset, and it is suitable for testing multiple consecutive samples. To get the final prediction, we averaged the probability outputs of multiple consecutive samples. And the result shows that the EER can converge locally to 3% after 8 consecutive swipes, and the AUC converges to 97%. There are still some limitations remain to be explored in our work. First, we designed only 2 tasks for collecting data. It is worth studying how gestures and the corresponding features vary with different tasks. And also, the gesture types are limited. We studied only swipe and tap separately. It will be interesting using multiple types of gestures to get it may get if we use multiple types of gestures together, we may get a faster and more accurate decision. Thirdly, considering the different developing rates of their bodies among girls and boys, it will be interesting to check the touch patterns across children genders. After training the classifiers for finer age groups of children, may increase the overall accuracy since children's body develops significantly every year. In the end, the accuracy is not sufficient for standalone deployment, but combining our method with other behavior, such as gait or content, can probably improve the performance and make it workable. Okay, in conclusion, we demonstrate the feasibility of using touch behaviors to automatically detect child users on smartphones. We extract features in terms of finger dexterity and hand geometry to assist on the detection. We finally evaluated the classifiers using a dataset collected from 17 children and 40 adults. That brings to the end of my presentation. Thank you very much.